Alright guys, welcome to the calculator part of the study guide. Again, you need to know how to use a calculator here. Math 9 is probably your best bet. If you don't know anything else, know how to do Math 9. And not every problem on the calculator section requires a calculator. Okay, some of them do, which is why you should have 3 minutes per question for MCQs. Okay. If you find that you are taking way more than 3 minutes per question, skip it, come back to it. In fact, I always highly suggest you start with the FRQs because worst case scenario, you guess on the MCQs. You got a 1 in 4 shot. So, average value, that's something that's not on the other study guide, but it is on this one because it does come up. So remember, average value is 1 over b minus a from a to b of f of x dx. 9 times out of 10 people forget this. Okay. So average value is going to be 1/2, okay, because 2 to 0 is 2, from 0 to 2 of this function. And I'm just going to put that in my calculator. So math 9, okay, we're going from 0 to 2 of this function here. So x squared and square root of x cubed, what was it? Plus 1. Oops, plus 1 dx. Okay. Now, I notice that all my answers are here in fraction, so I'm actually going to make the calculator do that by doing math 1, and that's 52/9. But you'll notice, of course, that's an answer choice. Okay, so don't forget to multiply by the half. So divide by 2. 26 over 9, which is answer choice A. Cool. All right, this one is an interesting one. Okay, so they give you a to b of f of x dx. Is this weird expression here? Okay, so they want the same thing. Oh, these are brackets, not absolute value. Okay, and you're gonna split it up like you normally do. This, you know, this right here is this a plus 2b. And this part, you're just going to do FTC on. So the integral of 5 is 5x, and we're going from a to b. So you just do f of b minus f of a plus 2b from over here, plus 5b minus 5a. Okay, just plugging in b minus a. Then combine like terms, so I have negative 4a's and 7b's. And then it got written the other way with the b first, so that's c. All right, number 3, the velocity is given by this function here. It's got trig, so make sure you are in radians. So if you're unsure, press mode, go down here, okay, see how it's on radian. If it's not, so if it's on degree, okay, you just go up to radian, press enter, and then get out of there. Just in case you don't know how to go from radians to degrees, make sure you are in radians or else it will be wrong. Okay. So we've got velocity. We know the position at 2 is 10. So x of 2 equals 10. Okay? And they want x of 5. So our bounds have to be 2 to 5. Because we have 2, we're looking for 5. So we must use those. A v of t is going to be x, which we're using for position. You can use p of t, that's totally acceptable. 5 minus x of 2. And you're looking for 5, which makes sense that you don't have it, and 2 is 10. Now this part, I'm going to put in my calculator. So, math 9, and we're going from 2 to 5 of this function here. X squared, well, delete. X squared cosine of x plus 2. and that's going to be 26.77, then round that last one, 8. And then to solve, we just add 10, which makes it 36.778. Answer choice D. Okay. All right, for this one. What most people do wrong is they just start plugging these in for K. Okay. Which, I mean, that is a method, and if all else fails, you can use it. It's definitely not the most efficient one, and it probably would not get you credit if this was an FRQ, but to each his own, I guess. So what we're going to do is basically they give us a function and they give us a bound, or sorry, they don't finish giving you bounds, but they give you the answer. So what we're going to do is just like before, FTC. So we've got the antiderivative of 2kx is kx squared, right? Because k is just a constant, minus x cubed over 3. And we're going from 0 to k. So we're going to plug in k. When I plug in k here, that's going to be k cubed minus k cubed over 3. And then when I plug in 0, that's all going to cancel. So minus 0 basically equals 18. All right, so this is 1k cubed minus a third k cubed is 2/3 k cubed. Right, because that'd be like a 3 over 3 minus 1 over 3 equals 18. Well, and we're going to solve by multiplying by the reciprocal. So 3 halves times 3 halves. So k cubed is equal to, that becomes a 1, that becomes a 9, 27. And the cubed root of 27 is 3. Okay. Again, I guess you can plug in. All right, number 5. So I know that this function is written incorrectly. Okay, first of all, it doesn't have a t in it. Okay, so I said put it here, -1/2 t. But I don't know what this original function was, so none of these answer choices actually give you the answer. Okay, but that's okay. So we're just gonna do it like it was an FRQ. So we got coffee being poured into a cup, and this is the temperature of it at any given time. I want to know the average temperature. Okay, since I have temperature, I want to know the average one. That's just an average value problem. So that's the 1 over b minus a from a to b of t of t. And we're going for the first 4 minutes, so we'll go with minutes, 1 over 4. And we're going from 0 to 4 of t of t dt. And then we're going to put in this function, okay, math 9, 0 to 4 of 70 plus 11 e raised to the -1/2 t. And you get 299.023. Okay. And then, so that's the change in temperature, which is the first reason you know this is a ridiculous question, because it's basically saying it got almost 300 degrees hotter in the first 4 minutes, so, or not hotter, it just has a change of this much in the first 4 minutes. Okay, not necessarily hotter. And then we divide by 4, and you get 74.756, okay, which is not on there. So I don't know what these are, but this would be your answer, and it's in degrees Fahrenheit. Also, I like my coffee a little bit hotter than that. So not a great question, but the concept still stands. You have to be able to do these average value problems. Okay, now moving on, number 6. So we've got an amusement park, okay, which is kind of the theme of this one, I guess. And We got hours down here, and we have people per hour. Okay. If there were 270 people in line, they want to know how many people waited in line for the first 4 hours. So this is people per hour. So this is a rate. Now to get an actual number of people, we got to go backwards and do an integral basically. We can't do an integral because we don't have a function, but we do have this area under a curve. So 0 to 4. Essentially, we have 2 trapezoids here. So the first one, here, I'm going to do some work down here. So for number 6, the first one we have 1/2. Height is 2. Base 1, so that'd be this right here, is 1,000 plus 1,200. That's my first one. Plus my second one, 1/2. The height is also 2 here. And base 1 is 1,200. Base 2 is only 400. Okay, so I'm just finding this area here. 2's cancel. Cool. So this is 2,200 plus 1,600, which is 3,800. Which of course I put as an answer choice, but it's not correct. Okay, because you have to account for the extra 275 people in there. So 275, that gets you 4075. This is the answer choice D. This is an FTC problem. You might not have done that formally, so we're actually going from 0 to 4 of f of t, let's say it. I don't think I gave you a, or r of t. Of r of t dt is r of big R of 0 minus big R of, r of 4 minus r of 0. And you know r of 0 is 275, which is why they had to add it over here. But I'm guessing this is how most people did it. They figured out the area under the curve and remembered that there were already 275 people in line. All right, number 7, we've done these kind of problems. Snow in, snow out, melting. Okay, so at 10 a.m., the temperature is trying to increase, okay, and it's melting snow at a rate here. Again, make sure you're in radians. There are 170 cubic yards of snow. How much snow remains at 5? Okay, so we're going from 0, because that's when it starts to get hot, and we're melting, and we are finishing, so we start at 10 and we finish at 5. That is what, 7 hours? And that's gonna be, just put in your calculator here. So math 9, and we're going from 0 to 7, so 10 a.m. to 5 p.m. of this function. 10 plus 8 cosine t over 3 dx. And that gives you 87.354. Okay. That's how much cubic yards of snow has melted. But that's not what they want to know. They want to know how much snow remains. Also, for those of you not paying attention right now, come tell me re-amends tomorrow. Just whisper to me, Miss Ibsen, re-amends, and I'll give you an extra credit point, okay? To see who is actually paying attention. Don't tell anybody else, though, okay? So say re-amends to me to get some extra credit tomorrow. So we've got tomorrow as in Thursday, the 13th. So we had 178 when we started, minus the amount that melted. So we have 178 minus 87.354. And we get 90.646 cubic yards, which is answer choice A. All right, so there are actually 9 multiple choice on the calculator version, but there's only 7 here, so there's still more I can ask you about. And then I have free response here for you. This is one of our classic FRQs, rate in versus rate out. So we got amusement park again. That's our theme for this one. I'm just not going out. Just okay. So we've got people entering at this rate, E, and leaving at that rate. Okay. And it's open from 9 a.m. to 11 p.m., so 9 to 2300. Okay. And when the gates open, there are no people, so we don't have to worry about adding extra. So the price of admission is $15 until 5 o'clock. Then after 5, it's $11. So we have 2 integrals to do here. The first one is going to be from 9, because that's when we open. We open at 9, until 5 p.m., which is 17 of E of t, because we're talking about people entering. Plus, our second one goes from 17 to 23 of E of t. Now, the reason I split it up like that is because each of them has a different value. This one earns me $15 a piece, whereas this one's 11. Okay. So we're basically going to run this integral twice. Okay. I already typed it in, but I'm going to retype it in for you so you can see. All right. So I go to y equals. Again, you can do this on Math 9. 5,600 divided by x squared minus 24x plus 160. All right. So put that whole thing in parentheses, or else it will only divide by the x squared sometimes. Let's set a window that's better. So we'll go from like -3 to, I don't know, 100. Let's just see if it fits in there. -3 to 100. And let's graph it. All right. So we want to know that from 9 to 17. So second, calculate, and then the integral is right there, number 7. So we're going from 9 to 17. And there it is right there, and it's giving me a value of, let me read this closer, 6,004.270 people come in between 9 a.m. and 5 p.m. Okay. Now we can do the exact same thing, second calculate, but I want to know that from 17 to 23. And that is going to be 1,271.783 people. Yes, I know that we don't have 0.238 people, but that'll help us get the most accurate in the end. Okay. Then we're just going to go ahead and multiply those. 15 times 6,004.27270. That's $90,064.05 that we got from the first set of people. And then the people after, we're going to have 11 times 1.283. And we're going to earn $13,000 from these guys. And then we add them up. 104,048.16. Technically, you should always round to that third decimal point, but since we're talking about dollars and cents, we're gonna go with an actual amount. Okay. All right, part B. We're having this function be h. So h is E minus L. E being positive makes sense. That's the rate at which people are entering. L is the rate at which people are leaving. Okay, so we're going to find h of 17 and h prime of 17. So h of 17 is just going to be 0 to 17 of E of t, and I'm going to go ahead and split it right away, minus 0 to 17 of L of t. This front one we've already got going. So second so we're here, second calculate, and we're gonna find that integral from 0 to 17, which is so basically that's the amount of people who came in between opening. Oh, sorry, this should be a 9. Let's try it again. Second calculate, these should all be 9s. So 9 to 17. There we go. Oh, we already calculated this up here. So 0, 0.4.275 minus, so that's the amount of people that came in from opening till 5 p.m. And then we have to figure out how many people are leaving. So what I would do if I were you is go down to y equals, let's turn off the first one, go down to the second one, and then we'll type in L, which is 9890 over x squared minus 38x plus 370. Again, make sure it's in parentheses. All right. Second, calculate value, not value. We're going to use that next, though. Second, calculate integral from 9 to 17. And we get 2279.107. And then we just subtract in the regular window. Which is equal to 3725.163. Okay. Now what's this mean? Well, we had a rate. We had 2 rates, and we went backward, which gives us an actual amount. Meaning, this is the amount of people that came in. This is the amount of people who left. So this means the number of people in the park at 5 p.m. All right, h prime of 17 is a little bit different because since h is defined by an integral, when I take its derivative, it just becomes e of t minus L of t. Since we have them in there, we can just figure them out. So let's talk about e of t first. Second, calculate, and we're not doing an integral though anymore. We're just finding the value. So value, and it wants to know where? 17. And it's 380.488. Okay, minus L of t. So y equals, and then we're just going to turn this one back on, this one off. Okay. And you know it's on because it's outlined in black there. So second, calculate, value, at 17. Oops. And that's 760.769. Okay. And then you're going to go ahead and just calculate that value by subtracting. 760.769. And you get negative 380.281. And this is in people per hour. If it really bothers you to have this, okay, go ahead and round that to negative 380 people per hour. Because it's a rate though, per hour is okay, because you can have an average amount of people per hour. But this means, okay, because it's negative, that people are leaving at this rate. Okay, more people are leaving than entering. So the way I would write this is the rate at which the number of people in the park is changing. Okay. In this case, you could say is decreasing. Okay, it's decreasing at that rate at 5 p.m. Which should make sense. Like, people are done with the amusement park at 5 and then they go home. Okay. So using the hours that the park is open, so from 9 to 23, what is the maximum number of people in the park at any given moment? How do we always find maximums? Taking the derivative. So since h of t means the people in the park, and I want it at a maximum, I just take the derivative. Well, h prime of t is equal to e of t minus L of t. Okay. And maxima and minima occur when the derivative is equal to 0. So I'm going to go to y equals. I'm going to turn this one off. I'm going to turn this one back on, except for I need e minus L. So I'm going to do subtract, and then I'm just going to re-enter that function. 9890 over, and then x squared minus 38x plus 370. All right. Now I want to know when that equals 0. So second calculate 0. Okay. And I know this is from 0 to like 100, but I know there's a 0 here. Okay. Because I can see it goes through the x-axis. So my left bound is going to be 9. And my right bound is going to be 23, because those are the values. Okay. Given to us, right? So it has to be between there. And then a guess is literally anything you want in between, because it appears it only crosses once. If it crosses twice, your guess is to help it narrow down which one. I'm going to go with 17, because that's another number we've been talking about. Okay, and then it tells you where the 0 is. Don't move your cursor. Okay, a bunch of people will be like, I can't find it, Miss Simpson. No, 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 it's there for you. So t is 15.795 hours. Okay. But that's when it happens. It wants to know the actual number of people in the park. Okay, so basically I'm going to take that and plug it back into h of t. So h of 15.795 is going to be 0 to 15.795 of e of t minus L of t. And it's a dang good thing that you left them in your calculator. Okay, so I'm just going to delete this excess here, because I want just e of t. All right, so e of t, L of t. And I want, second, calculate. I want the integral, right, because h itself is an integral. So 7. Between, not 0, 9. All of these are 9. Keep forgetting it opens at 9. All right, between 9 and you can put that whole answer in there, 15.795. And that's 5, 7, 5, 4, 7, 0, 1, 6, 5. All right, so that's how many people have entered from closing until, from opening, sorry, until 15 hours after midnight. So what's that, like 3 something? Almost 4. Minus the amount of people who've left. And those people exist, so we're going to figure out who they are by highlighting this one. Second calculate, 7. Okay, and we're going to go from 9, not 0, 9, to that same value, 15.795. And that is 1519.485. So people in minus people out gives me the actual value. Also, I know it's a maximum because I should have mentioned it here. when we were looking at the graph, it went like this. It went from positive to negative, which means the original went from increasing to decreasing, and thus a max. Okay. If it went the other way, it could have been a minimum, and that would not be good, because that's not what we're asking for. So if I have, I'm just putting this in here. And you get 3950.68 people. Okay, and if it makes you happy, you can round up to the nearest person. All right, that is your calculator study guide. And just like on the non-calculator study guide, if you got that, I'm going to go through the test and give you topic by topic exactly what's on there. Let me grab that test for you. All right, so just like the non-calculator version, the name of the game is the FTC. If you don't know the FTC, learn the FTC. Okay, so I got a Riemann sum. I'm not telling you what kind, but remember, there's right, left, midpoint, and trapezoidal. Then I got a graphical FTC. Okay, area under the curve. And then another one. Okay, then I have a properties. Oops. Properties of integrals, right? Where we can split it up or we can multiply by a constant. And if we flip it upside down, then we have to make it negative, things like that. Then I've got definitely a calculator problem and accumulation problem. Okay, again, which is an FTC, just in context. So in context, so I'm going to give you a word problem basically. Particle motion. Particle motion. Okay. This one, I'll just straight up tell you, is average value. Okay. I've got a problem like the one that I messed up on, like number 5. But that's not messed up. Then I've got another particle motion, total distance. That is something that did not come up on any of these study guides. So you need to know how to do total distance and how it's different from net distance. Okay, and then I have another accumulation word problem. Okay. There's only 9 MCQs because they take you about 3 minutes a piece. Okay. Then I've got 2 FRQs. Okay, the first one is about particle motion. Okay, and the next one is what I can only describe as like the magic square problems from Friday. So let me know if you have any questions. Study your hardest. You guys got this. See you when I see you. Have a great day.